Alright, we're still in Chapter 3, Section 3. Here we are on problem number 21. So I said still there because I'm working in that section, so you may just be jumping into this. Alright, so we have a realistic type problem. So the following two-way contingency table gives the breakdown of the population of adults in particular locale according to employment type and level of insurance. One of the things that ran through my mind as soon as I saw a contingency table, I immediately said that looks like Excel. So if I dump this into Excel, then I'll have a table just like that. So there, I've got the table with Excel now as well. So you can see how I kind of made the same kind of table. And the reason I did this was because of two things. One, I wanted to add up to see if all these added up to 1. If you can see, if I'm here adding up the columns, so this is the sum of the columns here, and this is the sum of the rows there. If I look at adding up the columns, all the columns on a 0.15, 0.85, 1. So it does add up to 1. So I've got that. And I know that there are going to be things that are going to be across all levels of insurance or across all skill sets, so adding up those probabilities and having those available is going to be handy here in this particular problem. Alright, so you can see the way I did that by taking it and putting it into Excel as a nice computing tool that you can use in these type of problems. Alright, so adult is selected at random. So, just out of the blue, taking a person, so that's going to be equally likely that it could be these. Well, the likelihood of these is given by the probabilities there in that table. So find each of the following probabilities. A, the probability that a person has a high level of life insurance. So this is going to be the probability that H, we're going to say H for high level of life insurance. So that would be the probability of, across any type of employment type, of all the highs. So if you look there, we'll go to adding those up. I'm back here to this column. So I'm going to add up that column. So that would be the probability of high given unskilled, plus high given semi-skilled, plus high given skilled, plus high given professional. That sums up to 0.15, as I did there in Excel. Okay, so B. So now we're going to look at the probability of high level of insurance, given that he does not have a professional position. Okay, so in this case we want the probability of high given the complement of professional. So this is one we're going to have to look at the equation again. So we have the probability of high intersecting the probability, so the set of the intersection of high insurance and not professional, divided by the probability of the complement of professional. Okay, so the intersection of high and not professional. So in this case we're going to be looking at, so here's professional and up to high. So we're going to look at this set up here. This is the intersection of, so all this is not professional and there's professional and high. So we're looking at those three cells there. So this is going to be 0.00 plus 0.08, 0.05 divided by, so we're looking at the probability of, so here's the probability of professional, so all the rest of these would be added in to be not professional. So that would be essentially from the column over here, that's the 0.26 plus 0.4 plus 0.26 again. Okay. So I look at this, I have to add all these up. Okay, this is going to be 0.33 divided by 0.24892. So 0.33. Did I have that right? So there's 13. I have the which intersect Wait a minute, what's that? Look, I looked back at my writing and that looked like a 2. This was this first example up here, the 0, 0. So that's not a 2, that's a 0. So, sorry about that. Can't read my own writing, so I need to fix that and that. Let's come back here again. So that was a P. Oh, stop it. 0.5, so 0.00. So it's 1.3 divided by 0.92. And that's approximately equal to 0.14. Make that approximate there. Okay, C. So now we want the probability the person has high insurance given that the person is professional. So we can look at that a couple different ways. It should just be, well, let's go through it. So the probability of high intersecting the probability of professional divided by the probability that the person is professional. So in this case, probability that is high given they're professional, probability high given they're professional. So that intersection is only that cell there. So this is 0.02. And the probability that the person is professional, that's the sum across here, the 0.08. So this equals 0.2. That should be 0.25, isn't it? Yeah, well, I keep asking myself that. I do that one in my head. 0.25. Great. D. So in D, determine whether or not the event has a high level of life insurance. So probability high level of life insurance, and has a professional position or independent. And probability of professional opinion are independent. So a couple ways to figure this one out. So we can look at this. So let's say if the probability of high insurance is the same probability of high insurance given that it's not independent. So if the probability of the high insurance is the same whether or not I know anything about the probability of them being professional. So if the probability of high is the same as the probability of not professional, then we should be, so if those two are equal, well, we know that they're independent. So the probability of high is, we looked at that one, that was this column, which is right here. Probability of high is, I did it again. Pressed the button on the side of my pen and started drawing all over. And the probability of high given the complement of professional, we calculated that one, that was 0.14. So these are not equal, so they're not independent. Because knowledge of professionalism influences the probability. There we go, with all my little extra scratches on the screen.